Alright, this stream, we'll call it Cocoon. Because you left the cocoon, and now we are in the new house. We're in the new house. We will start sleeping in the new house from today onwards. We made this stream when we first moved in on 31st. Then on 5th we got the internet. Until then we were doing streams on data. Then on 8th we got the bed frame. Today's 9th. We did more shopping. We bought more stuff. And finally we made the move. So this is really good. One thing I'm curious about is the pulse. Show me the pulse. Alright, perfect. New signals from... It's cool how it automatically creates all this stuff. New signals from AI Frontier Labs. Okay. Automation runs accessibility surfaces. Newly emphasized moves and signals since prior runs. Strictly focusing on model releases, research breakthroughs, acquisitions, and collaborations, avoiding repetition of earlier themes. Research breakthrough. It's funny how it shows lift a heavy mattress without strain, avoids tripping. Screws in IKEA furniture, tighten cam locks and screws only until snug to prevent crushing the particle board. Use a low torque setting on drills. Choosing cooler sheets for deep mattresses. Perkle Wave Cotton offers crisp, breathable comforts. Select fitted sheets with 30-40 centimeter pocket depth for a 28 centimeter mattress. How Martindale ratings define fabric durability. Morning test when BBC stays on X amid misinformation concerns. Very interesting. Okay. Internal work increasingly centers on reasoning-driven scientific discovery, especially simulation-heavy domains, materials chemistry, climate model direction, development of domain-specialized reasoning models, science-first and math-first variants within a single general release. Collaboration expanded, research collaborations with scientific institutions and national labs, positioning OpenAI models as research accelerators. Generally, I provided toward general scientific reasoning infrastructure. General scientific reasoning infrastructure. Anthropic. New results in mechanistic interpretability of planning circuits, improving the ability to audit long horizon decisions. Claude variance increasingly differentiated by deployment. Oh, that was interesting. Did Anthropic cut access of Claude code to all its competitors? This was actually very interesting. And this is exactly what should actually happen. Like if other frontier labs are actually using Claude code to make their own AI, they are too dependent on Claude code. Claude code is inevitably the best one. So, and it was actually interesting that Elon also accepted the fact that Claude Anthropic is doing something really good in coding, which even XAI hasn't achieved. So this actually made a lot of sense that the top dog, the top guy at XAI, he was like, this is actually a good opportunity for us to dog food our own product, use our own product to use our own product and get into the recursive loop of using the AI to build more AI. Deployment was clear, not just capability, collaboration, deeper engagement with standards, bodies and policymakers to translate alignment research into concrete governance frameworks. Anthropic is shaping both. But that's also interesting, like, yeah, if you've signed up with your company account, Cursor knows that, Claude knows that, but what about all the VPN ways, all the other ways that you might be using Claude code? That's interesting. You might be also giving it access. I think people can still test, people can still figure out like where is it good, where is it not good. But yeah, that's interesting. Like, yeah, otherwise you will end up in the tailwind like situation where people, yeah, people are benefiting from you, but you are not actually making a lot of money, because at the end of the day, you are also a business. You not only want to build a product that serves people, but you also want to make money. Deeper engagement with standards, bodies and policymakers to translate alignment research into concrete governance frameworks, shaping both aligned models and the rules that govern their use. Google DeepMind. Models generate and refine hypotheses with minimal human input. It's crazy. I feel like my fingers are gonna hurt tomorrow. We have really pushed the limits of our hands. Gemini research variants show improved cross-domain abstraction, math, diagrams, text. New joint research programs with universities and public research labs in life sciences and physics. DeepMind remains the clear leader in AI as a scientific discovery engine. XAI. Local processing. Interesting. Grok development emphasizes continuous adaptation from live data rather than static training cycles. Collaboration, early partnership with data-intensive platforms, news, markets, logistics to co-develop real-time reasoning systems. Continued investments in vertically integrate compute and data pipelines. XAI specializing in AI for fast-moving adversarial information environments. Fast-moving adversarial information environments. I think that's actually super powered that XAI can truly develop, because others don't have access to that data, and they're also not being asked about that data. But XAI is being people are constantly not only querying it, but it's also generating a lot of feedback. It's also acquiring a lot of first-party data, which is very interesting. Mistral. Open weight models designed for experimentation, rapid fine-tuning. Expand partnership with European universities and public research institutes. Selective acquihires of small research teams rather than large corporate acquisitions. Again, Mistral has to do the same thing. Mistral has to also go out and acquire the best talent if it has to win, and it has the opportunity to just take over the entire European market and just get the top research from there. Ideally, go target London, because London is where you have the best AI researchers. How did London end up having some of the top AI research talent? Meta AI. New findings on emergent coordination in a large population of agents studied using open weight llama variants. This is also interesting. Something today somebody was talking about, that how the Transformers paper was actually really simple. It was very different than all the other research papers, where other research papers would go into these complex hypotheticals and try to explain and come up with really complicated ideas. On the other hand, what the Transformers paper really did was make things very simple. But what was it exactly? Was the Transformers research paper really simple as compared to other research papers in the field of artificial intelligence? Cross-lab signals. Knew this one. Discovery simulation and hypotheses testing are becoming first-class benchmarks. Discovery simulation and hypotheses testing. Model families fragment. Frontier labs increasingly deploy specialized model families instead of one flagship. Model families. Alignment research and policy collaboration are now strategic differentiators. Governance as leverage. Tell me more. Collective intelligence rises, multi-agent population level behavior is an explicit research frontier. This week's frontier activity shows AI labs competing less on raw model launches and more on who can integrate deeply into science, governance, and real-time systems, laying groundwork for the next phase of frontier capability. Whoa. How did wait? This question is over here. It messed up. You quietly solve the talent for a problem early. University College London, Oxford, Cambridge, Imperial College London lean into machine learning. Oh, so this is how it shows. Imperial College London. This is Imperial College London. This is University College London. Oh my god, this is beautiful. This is University of Oxford. Oh wow. This is what you dream of, right? When you think about going to university. Wow. That was University of Oxford. 1096, founded, incorporated 1571. Most prestigious globally, academic excellence, influential alumni, groundbreaking research that shapes global knowledge and policy. Wow. Philosophy to medicine and AI. University contributed to Oxford, AstraZeneca, COVID-19 vaccine supplied to 180 plus countries. Stephen Hawking, Malala, Universe Head of State. Wow. What about this one? 1826. Okay. Foremost multidisciplinary universities known for its research strength, academic excellence, commitment to inclusivity, and innovation. London's Global University. Very cool. University of Cambridge. Wow. Wow. Okay, we want to visit this once. 1209. Wow, Royal Charter granted in 1231. Second oldest university in the English-speaking world. Wow. World's top academic institutions for research, teaching, and innovation. Scholarly legacy, make it a cornerstone of global higher education. Deborah Prentice. Golden Triangle Universities. Cambridge Cluster or Silicon Fen, leading innovation ecosystem, contributes nearly 30 billion annually to the UK economy. Disseminates education and qualifications to millions of learners globally. Alumni include Isaac Newton, Charles Darwin, Stephen Hawking. Wow. Intellectual and creative achievement. Machine learning as a first-class discipline, earlier than most US schools. UK PhD programs normalize shorter PhDs and industry collaboration, which reduce the opportunity cost of deep research. Shorter PhDs. I think that's the solution, right? Shorter PhDs. You can have 5-year PhDs now. You can have 5-year PhDs now. Wow. Study stream researchers who are comfortable moving between theory, engineering, and deployment. Pure academics and more hybrid researchers, the exact profile frontier labs crave. DeepMind anchored a gravity well. Change the study's trajectory, proof that world-class AI research didn't have to orbit Silicon Valley. Went on to see that the lab startup and academic groups, London gained something rare in institutional memory of frontier scale ML. Once that flywheel starts, it's self-reinforcing. The Alan Turing Institute unified theory, policy, practice. Subtle but decisive role, it acted as a neutral meeting ground between academia, government, and industry. Researchers could work on alignment, interpretability, and robustness without being logged into a single corporate agenda. London unusually strong in safety aware ML not capability scaling. That alignment bent later attracted labs that care about governance, not just benchmarks. Immigration policy for once helped. Eastern Europe, India, Africa, and the Middle East could relocate with fewer hoops. London became a convergence point for globally trained talent who didn't want to bet everything on US visas. Dense international talent leads to cross-pollination of ideas, not monocultures. AI thrives on heterogeneity. London optimized for thinking, not hype. This once cultural London has fewer demo day vibes than SF. More reading groups, fewer pitch decks, more tolerance for slow foundational work. The environment is especially attracted to people working on alignment, interpretability, and theory, where progress is lumpy and non-linear. Why this matters now today, London isn't trying to outskill Silicon Valley. Alignment and safety research, mechanistic interpretability, long horizon reasoning, AI governance and interfaces. Superalignment work or trace which subfields London is strongest in right now. Intellectual coordination becomes the scarce resource. London quietly excels at that. Interesting. Tell me about Vancouver and its initiatives, its strength in the field of AI. Don't be more Vancouver? What? What? Tell me about Vancouver. Rain Mountain's quietly grown into one of the North America's most interesting AI ecosystems, especially for research, industry integration, and real-world delivery. What? This is New York. Yes, this is something Vancouver. Academic heart of Vancouver's AI scene, world-class work in machine learning, vision, robotics, computational neuroscience. Deeply tied to health, ecology, and robotics lab, tied links to industry through clinical partners and applied research groups. UBC produces researchers who aren't just theoreticians, they build and deploy. Joint research chairs, conferences, and cross-province projects. This helps Vancouver researchers stay plugged in into Canada's broader AI research by interest. Co-equal node in a national network. AI is in the real world, not just labs. Isn't only theoretical, it's applied. Robotics and autonomous system. Coastal context, drones, and field robotics or environmental sensing, healthcare AI. UBC and local hospitals partner to build clinical models, AI for imaging, diagnostics, and health policy. Ecological and climate-oriented AI, predictive ecological models, resource management, and forestry applications. Impact in physical domains where data meets the real world, deep mind and big lab engagement. Reinforcement learning, multi-agent systems, interpretability collaborations. Close to nature, readily lower cost than Silicon Valley, high quality of life, welcoming tech community. International talent who might otherwise disappear into the US pipeline. A thriving startup scene with many efforts and AI-enabled companies, VCs and angel investors focusing on health tech, robotics, fintech, and climate tech. Easy collaboration across cities and labs. Less raw compute, big tech concentration, but more focused in depth in domain-specific applications and academia industry bridges. Applied depth rooted in real-world problems rather than trying to be another Silicon Valley. Global epicenter interpretability breakthrough is the way London and San Francisco labs might be, but it does produce Thinkers and builders can deploy alignment tools in real context, especially where AI touches safety, critical robotics, medical decision making, ecological stewardship. Practical alignment matters here, not just theoretical. Cohere analytics. Continue to publish large-scale semantic research, search, neural ranking models, scaling vector search pipelines. Layer AI-powered creative workflows, papers and posts on human AI interaction models, work on contextual memory structures. Thalamic labs. Preprints on muscle signal to semantic intent mappings, explorations of embodied interaction models with generative AI, brings physical world signals into AI perception research, a growing frontier. Triumph BCI infrastructure nodes. National lab ecosystems are co-sponsored research focused on accelerators for simulation and physics-informed ML. Core contributions, multi-layered representations, multimodal signal processing, domain-centric outputs, not just benchmarks, cross-disciplinary authorship, leading to broader uptake in real systems. DeepMind, academic spine built for theory, national better foundational science, immigration, culture that tolerates slow intelligence. Flywheel effects, hiring becomes easier, collaboration becomes denser, students see role models nearby, spin out feedback into the ecosystem. It won by being serious, deep theory, long-term horizons, global talent, institutions that outlast hype. Once it ferments, it's very hard to replicate. Very cool. Actually restricted access to Claude and Claude code for certain competitors and third-party integrations. Competitive concerns. Benchmark and assist with development of GPT-5. Terms of service that bar using Claude to build or improve competing products. Specific third-party tools lost access to. Open code similar tools to prevent people from bypassing its official interfaces and using the subscription in unintended ways. Earlier cuts to startups linked to competitors. Cut direct access for Windsurf, coding-focused platform, rumored to be tied to OpenAI acquisition talks. Unlikely to sell Claude to a competitor. Unlikely to sell Claude to a competitor. Very interesting. Because OpenAI wasn't talked to buy Windsurf, they didn't want Windsurf to have access to Claude, because then OpenAI would have access to Claude. That would be weird. That would be weird. Yeah, this is the weird thing. There will be bundling and unbundling, but you need to have a third party that is doing the bundling and unbundling. You cannot have OpenAI create an interface where it's like, oh yeah, you have also the option to, you can either use OpenAI models or you have the option to use Claude models. So the frontier labs cannot do the packaging. There has to be a third party doing the packaging, like Perplexity. Earlier cuts. Anticipated university ban on competitors forever. It has pulled access or tied in terms for specific players. It sees as using cloud in ways that could aid competing products. But in a very particular way. That Transformers paper remembered as deceptively simple. Remove complexity instead of adding it at a time when everyone else was doing the opposite. Here's the texture of that simplicity. One radical deletion. Before transformer sequence modeling meant RNNs, LSTMs, GRUs, gates on gates on gates. Delete recurrence entirely. No clever workaround, no hybrid compromise, just attention stacked and repeated. That kind of simplicity is rare in research because it's risky. Removing a core assumption usually breaks things. Here it didn't. A small set of reusable parts. The model is basically scaled dot product attention, multi-head attention, feed-forward layers, residual connections plus layer norm. No exotic math, no obscure probabilistic trickery. The components were already known. The novelty was how cleanly they were composed. This one rearranged existing Lego bricks into a shape no one had tried. Mentally simulate. Many AI papers feel like black boxes even after multiple reads. Trace a token through the architecture. You can trace a token through the architecture, understand why parallelization works, see exactly where inductive bias lives and where it doesn't. That cognitive clarity is part of why it spreads so fast. The insight. What if sequence order doesn't need to be baked into the architecture itself? Simple ideas are often the most expensive ones. They require discarding intellectual furniture you're used to sitting on. The confidence. Plenty of people had played with attention. Almost no one was willing to say attention alone is enough. That's not simplicity, that's conviction backed by taste. The timing. GPU's large data sets and parallel compute had just crossed a threshold where this idea could work. A decade earlier, it would have failed and been forgotten. Simplicity often looks obvious after infrastructure catches up. Mathematical density, number of moving parts, surface level technical intimidation. The NES transformers are simpler than many Bayesian ML papers, classical RL theory, earlier sequence models with intricate gating dynamics. Conceptual reorientation, long-term impact, how much it changed what people thought were necessary. It's one of the hardest papers in the field. Progress often comes from removing constraints, not adding cleverness. Overspecification is a tax on intelligence. That idea echoes far beyond NLP. It's almost a thesis statement for modern AI.